Sierra Software Tutorials. Digitizing Methods, Part 3. In this video, the third part of the tutorial on digitizing methods, we will explore the tools for manual digitizing. Manual or classic digitizing means that we have to capture the contours of our shapes by placing the nodes, one by one, manually. Let's remember that we are using circular arc-type curves. We will prepare a grid that is presented over our objects, with a dotted line type, light gray and 10 mm apart. It will help us to have a size reference. Let's start exploring the basic elements of our contours, the nodes. We will use a path with running stitches of 1.5 mm length with no repetitions. We have two basic types of nodes, straight and curved. We select the initial type from the Tool tab. The system places a node with each click we make. The segments between nodes are straight and we can make abrupt changes of direction between a segment and the next one. If we place a node in the wrong position, we press backspace to delete it. Each time we press backspace, the system deletes the last node in the sequence. By pressing the Enter key, we confirm the object and the system generates the stitches. Let's create another path to see some of the tools available. If we need to create objects with precise shapes, we can connect the snaps to the grid, forcing the nodes to be located at the intersections of the grid. Orthogonal, forcing the direction of the segments to be only vertical or horizontal. To a fixed configurable angle. Or to notable points of other objects as their nodes. Midpoint of segments. Perpendicular to a segment and other options. When we are creating a contour, as we approach to the first node, the mouse pointer changes shape slightly. This signal indicates that, if we click, the system will create a closed contour. We can also create a closed contour using the Close Shape command from the context menu, or by instructing the system to create a mirrored contour, using the Close with Mirror Shape command. Let's create some paths using curved nodes. While straight nodes are represented by a small square, curved nodes have a circular shape. As we can see, the position of a new node affects the shape of the curve between the two previous nodes. By default, the system adjusts the curves so that no abrupt changes in the nodes occur. If we need to digitize a smooth curve, we can place the nodes farther apart. And if we need to create a steeper curve, we should place them closer together. As with straight nodes, we can use snaps and the tools to create closed contours. No matter what type of node we select, we can change the type during contour capture. Although we can use the Tool tab buttons, the simplest way to do this is to use the Shift key. If we start using straight nodes, pressing and holding the Shift key will switch to curved and vice versa. Let's see an example. We start with curved nodes. A signal will appear on the screen when the Shift key is pressed. Let's observe how the curved segments restart after a straight node. If we close the contour, with a node type different from the first one, the type of the last node will prevail. There is another important property of nodes. Nodes can be normal, like all the ones we have inserted so far, or corner. When we are using curved nodes, a corner node allows us to abruptly change the curvature. To set a node as a corner while digitizing, we can press and hold the Control key. We can use the Shift and Control keys at the same time if necessary. While normal nodes are drawn with white fill color, curved nodes are drawn in light blue fill color. Let's see an example. This curved corner node allows us to continue with a completely different curve. When creating closed contours, if the last node is a corner, this property prevails. This last straight corner node allows us to close the shape with a straight segment and keep the curvature of the first segment we digitized. As we can see, the straight corner nodes have no effect on the contour when they are between straight segments. However, the corner property has an important effect on certain stitch types. Let's create a path with zigzag, 4 mm wide and with a density of 5 lines per millimeter. Using straight nodes, let's create a very simple shape and open a simulation view. Let's edit the object and start moving one of the nodes so that the angle changes. The system continues to generate the stitches under the same strategy, although when the angle exceeds a certain value, it starts rounding it to avoid very long stitches. Now let's edit the node, define that it is a corner node and repeat. We see how from a certain angle, the generation strategy changes, from the standard model we call swept, to a model we call mitered. And if we continue, it changes again, to a model we call capped. This happens because, when setting the node as a corner, we have not indicated a corner model and the system has set it to the default value, automatic. When a corner node is automatic, the system selects the corner model according to the angle. To maintain a uniform style in the corners of an object, we can force the corner nodes to one of the models, opening the options in the Tool tab button. Probably the most versatile model is mitered. If we create paths with curved corner nodes, the behavior is the same. Well, this is all we need to know about nodes, so let's open an image and create some objects manually. We will create a new design from the Document tabs and insert a raster image using the catalog. In the block menu, select Rescale and adjust the size so that this segment becomes 4 mm wide. We will center the image. Assign some transparency. And lock it. Let's arrange the needles in the default palette. Dark blue first. Red, then orange. Brown. Blue. And purple. Finally, select needle 1. We will start digitizing the text using column objects with zigzag and set underlay to medium and short stitches to level 2. We have straight node selected. For the letters, we will digitize the thin segments first. We will be using the Enter key to finish each object. Now the letter V. All the time, we are using the mouse wheel to zoom in and out quickly. We are using the Shift key to switch to curved nodes. Remember that when we create columns, we are defining the outline and the stitch directions at the same time. We must pay attention to the orientation of the dotted lines that connect the pairs of nodes. Instead of digitizing the next letter, we will copy the one we have previously digitized. Click Edit Object. The system pre-selects the last object created. Click and drag to define a rectangle that includes all the objects in the letter. Press Ctrl+C to copy the selected objects and Ctrl+V to paste them. Then drag the new block of objects to the correct position. We can use the keyboard arrows to adjust the position with precision. By pressing Enter, we unselect the objects. To continue with the next letter, we select Column with zigzag again. The system uses the same property values we used for our last column zigzag object. We digitize the shape holding the Shift key pressed for almost all nodes except for the last pair. Again, we will copy the objects we already have for the E letter, paste them and move to the proper position. And do the same for the next R letter. Select Column with zigzag again and continue with the I letter. We will digitize the N letter following the same style, narrow segments first and then the wide one. We will keep the stitches in a horizontal direction. Let's check in simulation view mode. Next character, we will start with the curved region. We will use straight nodes for the left side and curved nodes for the right side in this region. Letter I. For the letter A, we will start with the horizontal segment. And finally, we will copy the previously digitized N letter. Let's take a look to our text in simulation mode. We will start digitizing the Indian head, starting with the red regions. Select turning area with zigzag, 5 lines per millimeter density, medium underlay and short stitches to level 2. Let's activate Needle 2, switch to Curved Nodes, and start with this region. We will need some corner nodes. Add directions. Hit Enter key. Now this region, using the same object type. Add directions, and confirm with Enter. For the next region, we will use an uniform area object with pattern stitches. Set medium underlay and reset pole compensation. This compensation is used to minimize the narrowing caused by thread tension. It is most noticeable in zigzag stitches and when embroidering on soft fabrics. We are using normal curved nodes and some corner ones. And backspace to delete wrong nodes and enter proper ones. Let's add the direction line, and press Enter. For the next region, we will use a column object with zigzag. And the turning area zigzag for this one. Directions. And enter to finish. We will edit the object to slightly fix the contour. Select this node and move it a little. Seems it is not enough. So, we will insert a new node using the Insert Nodes command from the context menu. Then, we rearrange the nodes and press Enter. Let's select the same object type and digitize the next region. Directions. Let's activate Needle 3 to continue with the orange regions. We will use a cut line to create some effect. Then, add the directions for each subcontour. Let's take a look. Next region. We will use the same cut line effect for this object. Although the shape of these regions are more suitable for using in uniform area, by digitizing them with turning areas with a cut line we can generate the feather effect. Let's repeat for the next region. Add a cut line. Dot and the directions. Let's continue with the last orange region. We activate the Needle 4 and digitize the brown regions. Again, we will use a cut line and add directions for each subcontour. Next, brown region, with the same strategy. Activate needle 5 and digitize the blue regions. We will digitize the lower area of this shape using an uniform area with pattern. And we will use a turning area zigzag for the upper circular shape. Direction. Select turning area zigzag. Let's digitize the regions of the last color, purple. Cut line and then directions. The last one. Done. Let's check with a simulation view. We will force a thread trim at the end of each object, just to have a nicer view. Edit object, select all objects with a rectangle and using the object inspector, set trim to yes for all the objects in the block. We have created a design by manually digitizing all the shapes of a reference image, thus completing the tutorials on digitizing methods. Thank you for watching.